Hi, Rebecca. Rebecca,
Yes, sir.
you got a point.
What? A point?
Yeah, you got a point
For what?
for my being a generous teacher.
Oh, thank you.
No, you got one of the people that got the same number of correct answers on the scavenger hunt.
Oh, yay.
Yeah, don't say yay. You guys did horribly. The most correct answers was 4.
Against mine.
The most correct answers were 4.
Oh, well, like I said, it's your opinion against mine.
There you go. But whose counts? Come on, give it back to me, Rebecca. Don't just let me get away with this crap. Oh, we have 4 people in now. Wonderful. Nice to have you in, Blake, Dylan, and Joseph. Just wait around for a few more minutes to see who else decides to join in. I hope you guys didn't do anything stupid like go to the beach, have a party, or study this weekend.
I worked.
I did one of those things.
You did what?
One of those things.
Okay, Dylan, which was it?
Study.
No, don't study, Dylan. It's Labor Day weekend. I am not even having a test until next week. And by the way, guys, it will be on, the test will be on next Tuesday, okay? Just so that everybody is aware of that, all right? Ooh-wee. This is the easy one. Should be looking forward to this test. Kicking butt on it so that you have a nice percentage going into the second one. Why is there a certain lack of enthusiasm here?
I'm enthusiastic, but I just got here.
Okay, great for you, Dana.
Thank you.
Okay. If somebody could recommend a real good chiropractor, I would really enjoy it. That's the thing. When you get over a certain age, there are certain things that are more, it's things that you look forward to more than other things. It's like a good massage is better than sex any day. And I can see I'm not convincing you guys.
Why can't you have both?
You just want everything, don't you, Rebecca? You want me to give you a point and you want all this other stuff too.
I'm greedy.
There we go. There you go. Okay, we're about ready to start. My number of participants has gone down. I've only got 5 now. Who wants to make a bet with me?
On what?
On the percentage of people that that are going to be at these meetings after the test as opposed to before. My thing is, I'm saying that there's going to be a greater percentage after the test than before. What do you think, Dana?
I don't know. That's tough because I feel like people are just gonna like drop the class.
Uh,
I mean, this was like review,
yeah,
so maybe they'll start coming when it's not review anymore.
that's my fervent hope.
Yeah.
I mean, I really am worried because I've got like maybe 11 out of 30 some that are actually coming to these meetings. So I don't know whether they're just flat out bored with what I'm doing or whether they actually don't need anything. We'll find that out soon enough. And don't get freaked out by the number of questions, okay? Because how many of you have actually seen the pre-test, the practice test?
I have not.
Has anybody seen it?
No.
Well, it's like in the practice test, what happens is I give you a box and like I put the element out there and you have to tell me how many protons, neutrons, and electrons are in it, right? That's in a box. When I do it as a test, each one of those boxes has to be listed as a separate question. So that's why there are a whole bunch of questions. Oh, we have number 6. I think it's Jackson's here. Okay, guys, let's do a little bit of review while we're waiting for other people in here, okay? Joe, do you remember, first of all, do you remember how you recognize a single replacement reaction?
I don't remember. I just know there's three things.
Three
Three of
things?
them, then it's a single replacement, yeah.
Okay,
Like, in a sense, like what we're looking at right now. There's
this
three.
is exactly what we're looking at right now.
I reckon. That's how I just remember.
In a single replacement, you have an ionic compound and you have a neutral compound. And the whole deal is you have to look at the neutral compound versus the either the cation or the anion. And you know it goes, if the neutral compound is more active than the cation, it will go. All right, Joe? We have magnesium and silver. Okay, Joe?
Yep.
Which one is more active? Looking at this activity series, which one is more active, magnesium or silver?
Magnesium.
Okay, so is magnesium going to want to be ionic?
Yes.
Okay, keep that in mind, all right? So magnesium will want to end up being ionic. So I have my screen here. Is it ionic now, Joe?
No.
It's by itself. If you have an element listed by itself, it is neutral.
Yes.
What about the silver? Is the silver charged?
Yes.
So we have a choice. Which one would you, magnesium is more active than silver. So which one is going, if it has a choice, which one is going to have the charge?
Isn't it going to be the magnesium?
Magnesium will, because it's more active. So this reaction goes, and when it goes, I have magnesium nitrate plus silver metal. The magnesium replaces the silver in the silver nitrate, and the silver becomes neutral. And I have to do this, and I have to do that, and we're good. All well and good, Joseph? Joe, does this make sense to you?
Yes.
Okay, Jackson, you there, Jackson?
Yes, sir.
Okay, now you've got the second one. We have iron and we have copper chloride. Were you following what Joe was doing?
Yeah, so the iron is more active than the copper.
Okay, so which one is going to want to be ionic?
Ionic,
Which one wants to be ionic? The more active one or the less active one?
more active.
More active one wants to be ionic. So is the iron going to replace the copper?
Yes.
And we end up with what? You don't know. You don't know, do you, Jackson? You know that iron's hooked up with chlorine, right?
Yes.
Okay, and you also know that there's going to be copper in here as a neutral entity, right?
Yeah.
But what you don't know is you don't know whether this is going to be Fe. Jackson, talk.
It's a type 2.
It's a type 2, so you don't know what the charge on the iron is going to be.
Yeah.
So, guys, this is something that you need to realize. If you have a type 2 metal that is going to replace another metal, a type 2 metal is going to replace a cation, unless the teacher specifically tells you what the charge is on the iron, you don't know what the final compound is, and you can't balance this. So if you get a problem like this, best thing to do is to ask the teacher one, or if you can't get a hold of the teacher, then make up your own thing. You're just going to say, okay, well, this one, the iron is going to make an iron 2. And then argue it out with the teacher later. Does that make sense to you? If you argue it with me, I'll give you credit for it, for sure. Does that make sense? I will try my best when I'm dealing with single replacement reactions. I will try my best that the neutral metal is going to be a type 1 metal. But sometimes things slip by. If it does slip by, phone me up immediately, or if you can't get a hold of me because it's outside of the hours of 5:30 to 6:45, then put in your own charge and do the best you can from there, okay? All right, Rebecca, you out there?
Yep.
Okay, Rebecca, you have another one here. You got calcium and HCl. There's the activity series. Is calcium more or less active than hydrogen?
More.
So if I have calcium reacting with HCl, does the reaction go?
Calcium chloride on the first compound and just hydrogen by itself.
As?
2.
Thank you.
Right.
Okay. Now, let me throw another curve in on you. Oh, no. Okay. Chlorine. Is chlorine going to make an anion or a cation?
Anion.
So what you're doing when you have chlorine as a neutral compound, what you are doing is you're comparing it to the anion. Now, is chlorine more or less active than bromine? Look down here. More active. So if it's more active, do I get a reaction happening?
Yes.
Yeah, there we are. There we are. So if I get a reaction happening, sorry about this. This is coming up on me. What happens is the chlorine replaces the bromine. So I get MgCl2 plus Br2. You guys have this down, pretty much down? Questions about single replacement reactions?
Nope.
All right. Now, does anybody know if I have a chemical formula, how do I recognize it as being an acid?
It has hydrogen in it.
Hydrogen will be the first element in the formula. Two exceptions: water, hydrogen peroxide. If it's not water or hydrogen peroxide, then it is an acid. Okay? I'll lob another one at you. How do you recognize something as being a base? This one's not as easy. Sodium hydroxide, barium hydroxide, calcium hydroxide. What's that?
Has to have an oxide.
Not an oxide,
OH.
an hydroxide. So you recognize it as being an acid if one of the formulas begins with H. You recognize it as being a base by the other compound ending in OH. So
What were the two exceptions?
water. Water is not an acid, H2O. The other one is hydrogen peroxide. Those are the only two I know of. Okay? Now, if I have an acid-base reaction, it's just like a double replacement. As a matter of fact, if I put an acid base out there and you answer double replacement, I'll give you credit. What happens? First cation reacts with the second anion. The H reacts with the OH to make H2O. Then whatever's left, the C reacts with the anion of the first, we have Cb left. Couple things. Acid-base reactions always proceed. They always proceed. And the other thing, if I break my HB up into H plus and B minus, my COH into C plus and OH, I make water plus C plus and B minus. Now, Dylan, in my ionic equation, is there anything that's the same on left and right?
The B minus,
And
C plus.
I eliminate the B minus and C plus, and I get H plus OH minus yields water. Ladies and gentlemen, the other thing you need to know is, there are three things you need to know. One of which is the product is always water and a salt. Product is always, you take the H from the acid, hook it up with the OH from the base, you're going to make water. The other product is just going to be the cation from the base and the anion from the acid to make a salt. The other thing is that if I'm going to do a net ionic equation of any acid-base reaction, it's just going to be H plus OH minus yielding H2O. Third thing is it acts just like a double replacement reaction. So if I'm doing a real one, if I'm doing HCl plus NaOH yielding H2O plus NaCl, I recognize the HCl as being an acid, the NaOH as being a base. Therefore, it is an acid-base reaction. The products of this are going to be water. My cation for my base is sodium. My anion for my acid is chloride. So my salt that's formed is sodium chloride. Questions about this? Didn't have a chance to erase it from earlier. Okay, let's go with who's out there that I haven't bothered yet. Dana, I haven't bothered you yet. Dana,
Yeah.
I have H2SO4 and KOH. I recognize the sulfuric acid because it begins with an H. I recognize the KOH as a base because it ends in an OH. What are my two products?
H2O.
And
KSO4.
now, that looked ugly. Now, what is the charge on potassium?
+1.
+1. How about SO4, Dana?
Good question.
Good question. Now, do you want
It's
to know how to do some
-2.
legal cheating, Dana?
Yeah, give it to me.
Okay, let's look at this guy. When I give you the reactants, they are already balanced. Okay?
Okay.
Do you know what charge an H plus has?
Isn't it +1?
Okay, how many of them do I have?
2.
So what's the charge on the SO4?
-2.
Let the test help you. I never, to be honest with you, I never memorized the charges on the anions. Never memorized them because I figured I could always figure it out. So if potassium's a +1 and SO4 is a -2, what goes right here as a subscript of K, Dana?
2.
And all I got to do now is do this. We're balanced. Okay, who else haven't I bothered? Blake, I haven't bothered you yet, Blake. You out there, Blake?
I am.
Okay, H3PO4 and NaOH. What are the products? Does it begin with H?
It does.
Does it end in OH?
It does.
So what has to be one of the products?
H2O.
That's a gimme, guys. That is always going to be a gimme with acid-base reactions. Always form H2O. Now, what's left, Blake?
The P, the sodium, and yeah, that's it.
And what else?
Oh, is there another? There's another O.
No.
Wait, no.
What's,
It's P, potassium.
and what else is here?
An oxygen.
How many of the oxygens?
There's 4 of them.
Thank you.
Yes.
So I got NaPO4. Same question that I asked Dana. What's the charge on PO4?
A -3.
So how many sodiums do I have?
Negative, or 3 of them? Or
3 of them.
yeah.
Okay. Are we kind of understanding how these things are going?
So I have a question.
I have an answer.
So on these, you can change the subscript
I'm sorry, I'm not understanding what you're saying.
because where you put the 3 next to the sodium, that would be a subscript, correct?
That's a subscript. I just didn't, if you really want to be technical on me, see, that's why I didn't want to do it.
Yeah, no, that's fine. So you can change the subscripts on these, like when you balance it out.
You have to balance the compound, Rebecca.
Oh,
You have
okay,
to
okay.
you have to balance the compound before you can balance the reaction. At this
Gotcha.
point, I know I have 3 sodiums, so a 3 goes in front of NaOH. Then I have 3 H's and another 3 H's. I'm going to have a 3 in front of there, and I'm balanced out.
Okay, got it.
All right. Good, you're here, Rebecca. What kind of reaction is this? Do I have an acid? Do I have an acid, Rebecca?
Yes.
Do I have a base?
Yes.
Does it end in OH?
Oh, no.
Do I have an acid-base reaction?
No, it's just a double replacement.
Double replacement. In that case, what you do is, what are my products, Rebecca?
Al.
Oh, you're going to go that way on me. All right.
SO3 and then H2Cl3.
No, never carry over subscripts.
Or HCl.
HCl. Is HCl balanced?
No.
What's the
You
charge on
need-
H?
1.
What's the
Negative
charge
1.
on Cl?
Positive 3.
Cl?
Right? Oh, wait. Hold on. I didn't have a periodic table.
Uh-huh. That's a fine excuse.
Hold on. Positive 1.
Try again.
Right.
Is it on the right side of the periodic
negative.
chart? Negative
Negative
ones.
1.
So you have a positive one and a negative one. Is HCl balanced?
Yes.
Okay. So you said H was a positive 1. What's the charge on SO3 then?
Negative 2.
So aluminum is a positive 3. SO3 is a negative 2. What are the subscripts here?
2
Faster.
and 3. 2 and 3.
2 and 3. So we balance this. How many, what goes in front of this AlCl3?
A 2.
And what goes in front of this H2SO3?
A 3.
3. So we now have six H's and 6 chlorides. So we get a 6 over there. And we're balanced. Okay?
Yep.
Questions about acid-base reactions? Next one we're going to get into is a combustion reaction. A combustion reaction, you identify it. One of the reactants is going to be a hydrocarbon. Rebecca, hydrocarbon. What do you think makes up a hydrocarbon?
Hydrogen and a carbon.
There we go. So you're going to look at the compound. If it has hydrogen and carbon in it as one of the reactants and oxygen as the second, you have a combustion reaction. This is a gimme, guys. All you got to do is recognize it. Then you know that the two products are going to be water and carbon dioxide. Now, the real interesting thing about this is balancing them. It's a little bit different than balancing a regular reaction. If I have a combustion reaction, I'm going to balance the C's first. Then I'm going to balance the H's. If, excuse me, if the coefficient in front of water is even, then all you got to do is balance the O's. If the coefficient in front of water is odd, double it. Then rebalance the H's. Then you're going to have to rebalance the C's. Then once that's all done, balance the O's. So, Jackson.
Yeah.
I have, obviously, a hydrocarbon and I have water. What are the two products going to be, Jackson?
Water and carbon dioxide.
Always, each and every time. So I got water and I got CO2. Okay, Jackson. By my rules, I balance the carbons first. So what goes in front of the CO2?
6.
Okay. Next, I balance the hydrogens. What goes in front of H2O?
6.
So, is the number in front of H2O even?
Yes.
So all I have to do is now balance the O's. So Jackson, how many oxygens are contributed by the H2O?
6.
Say it. Don't say say it. Say
6.
it. 6. Okay, we got 6 from H2O. How many from CO2?
12.
6 and 12 is,
18.
so what goes in front of the oxygen?
18.
If I do that, then I've got
Oh, sorry,
18.
9.
Thank you. Okay? We good, Jackson? You feel confident about this?
Yeah, I do. I feel better now. Thank you.
Okay, let's go. Min, you there, Min?
Yeah, I'm here.
Okay, I have a hydrocarbon and I have an oxygen. What are my two products?
H2O and CO2.
Okay, man. How many carbons do I have over here?
3.
What number goes in front of the CO3?
3.
Okay. How many hydrogens do I have?
8.
What number goes in front of H2O?
4.
Is that number even?
Yeah.
So all I have to do is balance the O's now. How many O's from H2O?
4.
From the CO2?
CO2 6.
4 and 6 are
Total
10. What number
Right.
goes in front of the O2?
5.
Easy enough, easy peasy, right? So let's go with Dylan. And I'm sorry, guys, that I'm keeping on calling on you, but there are less of you here than normal. Dylan,
Yep.
do I have a hydrocarbon?
Yes.
Okay. All right. What am I? If I have a hydrocarbon and oxygen, I have a combustion reaction. What are my two products?
Carbon dioxide and water.
Yeah, you would mention it backwards. My hand was on the H already, so you got it in this form. All right. Now, Dylan, I got how many carbons on the left?
6.
What goes in front of CO2?
6.
How many hydrogens do I have?
6.
What goes in front of H2O?
6.
If I put 6 in front of H2O, that means 6 times H2. I have 12 hydrogens on the right and only 6 on the left. What number goes on the right?
3.
3. Is that an even or an odd number?
Odd.
All right, remember what I said. If the number in front of H2O is odd, you have to double it. So the 3 becomes a 6. Now you have to go back, balance the H's. What number goes in front of C6H6?
2.
Now I have 12 carbons. What number goes in front of CO2?
12.
All right, last thing, I gotta balance the O's. How many O's from H2O?
6.
And how many O's from CO2?
24.
So I have 30 O's. What number goes in front of the O2?
15.
Are you seeing how this works? If
Yep.
you guys weren't shown this before, doesn't it make combustion reactions so much more easy? Or am I just going over stuff you've already had before?
No, this makes it way better.
All right. Now, do you want to know why this happens this way? Why you have to double it and do those things?
Yeah.
Jackson,
Yes.
this is an O2. If I'm looking at the left side of this equation, is the number of oxygens ever going to be odd?
No.
Will never happen. So let's look at the other side. I have CO2. Are the number of oxygens contributed by CO2 ever going to be odd?
No.
Because whatever number you have up here is going to be multiplied by 2. Okay? Remember, when I said it was an even number in front of H2O, if I have an even number in front of H2O, then an even number times 1 is going to give me an even number, right?
Yeah.
Right? So then I have an even number plus an even number, I've got an even number on the right side. I can have an even number on the left. It will balance. On the other hand, if I have an even number here and I have an odd number in front of the H2O, that's going to give me an odd number of oxygens contributed by the H2O added to an even number contributed by the CO2. The right side is always going to be odd and the left side is always going to be even. I will never be able to match them up. That is why I said when you have an odd number in front of H2O, double it. That will automatically make the amount of oxygens even on the right side as well. Does that make sense to you?
Yes.
All right. Are we good with combustions? We good
Yeah.
with combustion reactions?
Yep.
Good. Now, when you have a decomposition reaction, for the most part, you are not going to be able to predict what happens. Basically, you're going to just be able to recognize it because you have something big and it goes to something small. Okay? You have a complicated molecule that gets broken down into simpler molecules. Specifically, if we are dealing with chlorates or perchlorates, I need to fix the slide. If I'm dealing with perchlorates or chlorates, and I heat a chlorate or a perchlorate, what happens is I make the chloride salt and oxygen. And the chloride salt is always going to have the same subscript as the chlorate perchlorate. If the chlorate or the perchlorate has an even subscript, just balance the O's. If the chloride, perchlorate, let's do this. If the chlorate or the perchlorate has an odd subscript, then balance the O's by doubling it, then balance the metal and the chlorine. All right, I have AlClO3, and I heat that up. What happens is I go from this big monster of a molecule down to two simpler ones, one AlCl3 and OH. Okay? The metal chloride will always have the same subscript as the chlorate. The chloride will always have the same subscript as the subscript on the chlorate. Now, I have 9 O's on my left. My right will always be even. So I'm going to have to double that. If I double that, I'm going to have to double this. So literally speaking, I've got 2 aluminums. I've got 3 times 2, 6 chlorines, 2 aluminums, 6 chlorines. So my aluminums and chlorines are done. I have 3 times 3, 9 times 2, 18 oxygens. All I got to do is put a 9 there. And I am balanced. No idea how I got the rest of this crap in there. The other one you have to recognize, if you have a bicarbonate is an anion of HCO3, and you heat that. You make out of that a carbonate, water, and CO2. So if I take sodium bicarbonate and heat it, I make a carbonate, sodium carbonate, plus water, plus CO2. 2 sodiums here, 2 has to go in front of that. That gives me 2 H's and 1 O, and a CO2 is left. If I have magnesium bicarbonate, again, I create the carbonate first, the magnesium and the carbonate. Okay, but I've got two H's. Here's my two H's. I got an O and O. And what's left is two CO2s. Are we good with this?
Yep.
Questions? Talk to me, because these last two things, I don't believe you had them in intro. You may have had the chlorate, perchlorate, but you didn't have the carbonate. Are we good? We kind of under, if you've got a question, now is the perfect time. Last type of reaction. And literally speaking, the only thing you're going to have to know from this is a synthesis reaction or a combination reaction is two simple molecules getting combined together to make a more complicated one. If I have two H2s and react one O2, those are simple molecules. They make a more complicated one, H2O. N2 plus three H2s make a more complicated NH3. Magnesium plus oxygen makes a more complicated molecule, MgO. That's all you need to know. All you need to do is be able to recognize a synthesis reaction. All right, the last, I promise, the very, very last reaction is something called oxidation reduction. These are two processes that occur simultaneously. You don't have electrical charge just normally happening in the atmosphere. That's because if something loses electrons, something else gains them. The process of losing electrons is called oxidation. The process of gaining electrons is called reduction. You will not have one happen without the other. Where you've seen this before is in the single replacement reactions. The neutral element goes from zero charge to a plus charge. That neutral element had to lose electrons. The neutral element gets oxidized. On the other hand, the element which began as a cation went from a cation having a positive charge to being neutral. So it had to gain electrons to do that. So if I have something like magnesium reacting with copper chloride to make magnesium chloride and copper, what is really happening is magnesium neutral is going to magnesium plus 2, and copper plus 2 is going to copper because the two chlorines cancel out. If I would write this as a half reaction, in other words, half of the whole thing that's going on, I have magnesium going to Mg plus 2, but it's losing electrons. The copper is then gaining those two electrons to become a neutral species. And there's an easy way to remember this. Leo goes Gur, loss of electrons is oxidation, LEO, or Gur, gain of electrons is reduction. If you don't like that, use oil rig. Oxidation is loss of electrons. Oxidation is loss. Reduction is gain, oil rig. I don't care which one you use, I stole both of them. And this is basically the last slide. The other two slides are something I was doing to help another student after class this morning. Any questions on reactions? I expect you to be able to identify the type of reaction if I just give you the reactants. I expect you to be able to predict what the products would do. I expect you to be able to determine if the reaction goes. And last thing, I expect you to be able to balance the chemicals, and balance the entire chemical reaction. Questions? If that's all, then we are going to go to another thing. Okay, we're going to moles. We're going to talk first about mole conversions. Very, very brief. We're not going to delve into this too much. We're going to deal with atomic weights. Then we're going to get into empirical formulas and percent composition. I probably will not be able to get into these last two things. I probably will not touch that. So I need to deal with mole conversions and atomic weights today. A mole. Okay, it's not this. It's the ugly thing that's on your face that has hairs growing out of it. Dylan, if I have a pile of marbles and those marbles weigh 394.80 grams and 10 marbles weigh 37.60, can you tell me how I'm going to figure out how many marbles are in that pile?
Take 37.60, divide that by 10,
That gives you the weight per one marble.
and then take 394.80 and divide that by the weight per marble.
Pretty much. That's what I do. So basically, we're going to be doing the same thing using this type of problem. That's what we're doing when we're messing around with moles. Now, what weighs more? What weighs more, a pound of feathers or a pound of gold?
Either.
They both weigh the same.
Are you sure?
Yeah.
Absolutely, Rebecca. You would be willing to bet your test grade on this. A versus F.
Yep.
100%.
100%.
No doubt at all in your mind.
Nope.
Cancel the bet,
Rebecca?
cancel the bet.
Joseph? What'd you say, Joseph? Anybody
Ah,
else want
nothing.
in on this bet? A or F, Rebecca? You sure you're still
A.
in?
Yep. I say
Eh.
A.
F.
What?
Gold is weighed in troy ounces, 12 ounces to a pound. Feathers are
come
weighed in
on.
avoirdupois, 16 ounces to a pound. So Rebecca, don't even bother studying. You got an F.
Ugh. Fine.
I'm kidding you, Rebecca. The real question we really want to ask, what has more molecules, a pound of gold or a pound of lead? I got you in front of me, Rebecca.
Yeah.
Which one do you think has more molecules, a pound of gold or a pound of lead?
Can I look in the periodic table?
Go for it.
All right.
And remember the marbles. I can't remember the marbles because I've lost mine.
I'd say the gold because it's lighter.
Very good. If you look at the weight of gold, that is 193, Rebecca? 192? You just had it a second ago.
These periodic tables don't have the weight on them.
Okay.
196. Yep.
197. It's 196.97. 197
Yeah.
for gold and 207.2 for lead.
Yep.
So if I've got the same amount of weight of both of them, and I'm dividing by a smaller number in the case of gold, then gold is going to have more molecules if we start off with the same weight. Now, Rebecca, I've got you. You own a paper factory, okay? And St.
Mhm.
Petersburg College ordered 602, comma, 200, comma, 0000000000000000000 sheets of paper. You own this factory. Would you count each sheet by hand to make sure that St. Petersburg College didn't get gypped?
No.
What would you use?
Dwight.
How do you buy paper, Rebecca? You go into Office Depot.
Yes, I buy them in stacks of 100.
Stacks of 100?
Yeah, I think so.
Somebody else out there, how do you buy paper?
With your credit card?
Oh, thank you. I need a comedian here, Joseph. You just stuck me right in the heart.
Yeah, I had to.
What does paper come in? What unit? Any of you ever heard of a ream?
No.
No? Those packets you buy paper in. That's called a ream. It has 500 sheets in it. So basically, you have 500 sheets in a ream, you have 10 reams in a carton, and you can put 100 cartons on a pallet. So basically, all you need to do is put 120 pallets in each semi-truck, and then if you're the owner, all you got to do is count the trucks as they leave. We're using counting numbers, ladies and gentlemen. 500 sheets per ream is a counting number. A ream is a counting number. If you have a ream's worth of pork chops, you have 500 pork chops. You guys have been doing this forever.
You didn't say it was printing paper.
Oh, ah.
Like if I'm buying like college rule, it comes in like 100 papers or something.
Yeah, that's what I was talking about.
I'm talking about paper for your printer. Leave me alone. How many, okay, Joe, how many desks do you have if you have a ream's worth of desks?
One.
No,
don't know.
Joe. You have how many of them? Remember, a ream is a
500.
counting number.
500.
How many pair of shoes do you have in your closet, Joe?
2.
2 pairs?
1. I get where you're going with this.
Thank you. If you have a pair of shoes, you have 2 shoes, right?
Yes.
If you have a ream's worth of shoes, you have 500 of them. These are nothing more than counting numbers. A mole is a counting number. Scientists are lazy. Chemists are lazy. I don't want to sit there and count each atom as they go by. If I have a dozen, I have 12 of anything. A dozen waffle irons is 12 waffle irons. If I have a ream of poodles, that's a 500 poodles. It's the same thing, only in the case of Avogadro's number, 1 mole is equal to 6.022 times 10 to the 23rd anythings. So how did this number originate? Remember way back when I told you that we use carbon as a standard? Carbon 12 has 6 protons. Each one of those protons weighs 1.67 times 10 to the negative 22nd grams. If I have 6 neutrons, they equal the same thing. So I get the total weight of a carbon atom is 1.994 times 10 to the negative 23rd. Now, let's just say I multiply for each proton, that's a 1, and each neutron, that's a 1. So I have 12 protons and neutrons. So if I take the number 12 and I divide it by the gram per carbon atom, I end up having Avogadro's number. That's how they figured out what Avogadro's number really was. So we're lazy. We don't like to sit there and count atoms or molecules. So what we do is we equate 1 mole to that number of atoms, and that equals 1 mole. If it happens to be carbon, I know that this many carbon atoms equals 12.01 grams. And remember, a mole is 6.022 times 10 to the 23rd of anything. If I'm dealing with elements, it's that many atoms. If I'm dealing with compounds, it's that many molecules. If I'm dealing with that many ions, it's that many ions. So we have some relationships. We've defined a mole as 6.022 times 10 to the 23rd atoms. We have also defined a mole as the atomic weight of that amount of element or the molecular weight of that amount of a compound. And we've also defined the molecular weight as being that many molecules or the atomic weight being that many atoms. We have 3 relationships to work with. We have 3 relationships to work with, and then it just becomes a dimensional analysis problem. If I have weight in the terms of grams and I want to get moles, what I want goes on the right side of the equal side. What I have goes on the left. What I have in being the weight is going to be grams. That's going to go on the bottom because I want to cancel out grams. I want to end up with moles, so moles goes on the top. So literally speaking, I have to put the number that's equal to 1 mole. That would be the molecular weight of my compound. So to go from weights to moles, I take my weight, divide it by the molecular weight. This will give me moles. If I have 23.495 grams of sodium chloride, I have a molecular weight. I have the atomic weight of sodium being this, the atomic weight of chlorine being this. I add the 2 of them together, I have 58.443. All I have to do is take the amount of grams, divide it by the grams per 1 mole. That will give me the amount of moles. In this case, that would be 4.40202. I'm not going to go through all of these. There are 6 of them. Guys, I think you can pretty much figure it out. This, from your perspective, there are two conversions you really need to know. You really need to know how to go from weight to moles, and you need to go from moles to weight. If you have the moles and you want the weight, it's a simple matter of multiplying it by the molecular weight over 1 mole. So moles times the molecular weight will give you grams. Does anybody have any questions about these? Do I need to go into these in any more detail? If you do, I'll be happy to do it. I got 15 minutes left. I'm hearing crickets. If you're having problems with this and you don't feel the necessity of speaking out now, then look through the PowerPoint. I go through each one of the conversions individually. Go into the online outline. That's a very, very good video on conversion of moles from one thing to the other. But if you guys aren't speaking up, I'm going to go on because I think pretty much you guys know this already. There's one other conversion factor that you have to know, and that is at standard temperature and pressure, which means if the temperature is 0 degrees and the pressure is 1 atmosphere, and only under those conditions, then you get 1 mole of a gas is equal to 22.414 liters of that gas. So how many liters of CO2 at STP are there if you have 14.68 grams? Now, you know there's a relationship at STP between moles and liters. So if you can just get moles, you'd be able to plug that in. And you can get moles because you know what the grams are and you know what the molecular formula is. I have 14.68 grams. I multiply that by 1 mole over the molecular weight of CO2. This gives me the moles of CO2. I then multiply the moles of CO2 by 22.414 liters per mole. That will give me liters. Questions on this?
So does STP pertain to all gases?
Yes.
Okay.
If I had argon, and say I had 32 grams of argon, argon weighs 40 grams per mole. So if I have 30 grams and I'm multiplying that by 1 mole over 40, this means I have 0.750 moles of argon. The 0.750 moles of argon gets multiplied by this number, and that ends up being for argon, that would be 16.8 liters. Questions on this? You can also take it the other way. If you have 43.5 liters at STP, you want to know how many grams of O. Well, I've got the gas at STP. I can generate moles by taking the 43.5, dividing that by 22.414. This gives me the moles of oxygen I have. Then once I have the moles of oxygen, I just multiply by the molecular weight. Remember, if I'm dealing with oxygen gas, that means it's O2. So the molecular weight of O2 is going to be 32 grams per mole. Multiply that by 1.94, I end up with 62.1. Questions, guys? Okay, last subject I'm going to talk about today because I don't want to get too far ahead of the morning class. Basically, up to this point, the molar mass, molecular mass, the molecular weights we've been asked to determine have been fairly easy. Basically, if you have sodium chloride, you know all you have to do is add up the atomic weight of sodium and the atomic weight of chlorine. Add them together, you have the molecular weight of sodium chloride. Sometimes the molecules get a little bit complicated. And I'm just using this. You don't have to use it. If you've got a system for getting molecular weights down, great, use it. I'm just using this as an alternative. And by that, I say use a table. By a table, I mean what you're going to do is you're going to list the type of element that's in the formula, the number of atoms of that type of element, the atomic weight. Then what you're going to do is you're going to take the number times the atomic weight, and this will be the contribution from that particular element. Last, all you got to do is add up all the contributions. You have your molecular weight. I have Al2 SO4 taken 3 times. Dana. I think Dana's out feeding the cat. Jackson.
Yeah.
I have Al2 in parentheses SO4 taken 3 times. How many ALs do I have in this formula?
Two,
Okay, how many S's?
3,
And O's?
12.
Okay, so I'm going to make a table out of this. My aluminum, I have 2 of them. My atomic weight is 26.98. I multiply 2 by the 26.98. I get the contribution from aluminum being 53.96. I have 3 sulfurs. I multiply that by the atomic weight. That gives me 96.18 grams. Sulfur's contribution. I have oxygen 12. The atomic weight is 16. 12 times 16 gives me 192. I add these 3 contributions up. I get 342.14 is the molecular weight for aluminum sulfate. Yeah, this is a silly slide. Basically, it's saying that shouldn't we be counting the electrons? Electron weight is insignificant. Don't worry about it. Okay. Jackson, since you already worked a hard one, you do KBR. Dylan, PbO2. Joseph, you got the hard one. NH4 taken twice, HPO4. Min, SN, C2H3O2 taken twice. And Rebecca, Fe2, Cr2O7 taken 3 times. And Dana has buggered out. No, Dana's there. Dana, do NH4 taken twice, HPO4. Dylan, SN, C2, H3O2. And I think that's everybody. I want you to work out those molecular weights now. I will be back momentarily. Okay, guys, who's got KBR?
I do.
What is it?
119.
Roughly speaking, 119. Lead 4 oxide.
329.2.
200, I'm sorry, what did you say?
239.2.
207.2 plus 2 oxygens gives you about 239. Good. How about my ammonium hydrogen phosphate?
I got 132.06.
Does that agree with the other person that did it? Who else did ammonium hydrogen phosphate? Okay, we're gonna have to go with it. We got 2 times 14, 28. 28 plus 4 times 2, 36. Another hydrogen, 37. Phosphorus is 31. 4, 68. 68 plus 64 leaves me about 126. Is that what you got?
I got 132.
Okay. You're gonna make me do this out by
I
hand.
got
I
2
know it's
N's, 9 8.
28. 2 ends are 28
Yeah, and I got 9 hydrogens.
for 9,
Yeah, and then I got 1 phosphorus.
31,
That's it.
and
And 4
and-
oxygens.
for 64.
Yes. Comes out roughly 132.
132 or 142?
30.
17, 18, yeah. Okay, you win.
I
How
know.
about my tin 2 acetate?
Yeah. 236.81.
Does that agree with the other person?
Can you say it again?
So Min, what was the number?
236.81 gram.
236.81.
I got 0.798, but yeah.
Close enough. Basically, you got to realize that the molecular weights are going to change a little bit depending upon which one you use. Okay? So you may have used 2 of the elements with a little bit of a different atomic weight. All right, how about my iron dichromate?
759.5.
759.5. Ooh, I really don't like you, do I?
What?
No, I don't like you. I made you do one with a big number. What about the other person that did the iron dichromate? You're gonna make me go and do this, guys? 55.85 times 2. I got 111.90 contribution from the iron. Chromium is 52 times 6, 312. Oxygen, I got 21 times 16. I'm sorry, that's too much to do in my head. 336 plus 312 plus 111.90. I got 759.9. Are we good? Ladies and gentlemen, are we good?
So are you gonna give us a periodic table so that our
Yes.
atomic weights are the same? Okay.
Yes, I will give you a periodic table. Now, how do you choose which atomic weight you use? Do you remember what I told you to do? Say, for example, you have 400 grams of potassium bromide. Okay? If you have, how much did I just say? I'm losing my head. 400 grams? How many significant figures in 400?
1.
1. So if I'm using 1 significant figure as my data, then I can use 39 for my potassium and 80 for my bromine. So if I have 400 grams, I can multiply that by 1 mole over 119. And I'm not doing anything wrong. However, if I have 6.832, that means I have 4 significant figures for my data. This means I'm going to have to use 39.10 for my potassium, and I'm going to have to use 79.90 for my bromine. Does that make sense to you all?
Yeah.
You don't want to limit your data by your atomic numbers. If I use 39 and 79, or 39 and 80, then I would be limiting my significant figures down to 3 when my data had 4. Okay, guys, that's all I have for tonight. We have to, those of you that are in the lab, I will be joining you probably at 1/4 after. Remember I said that I was going to do that at 1/4 after because it takes about a half an hour to upload these recordings.
Can I ask you a quick question about the exam?
Yeah, Dylan, go for it.
I get time and a half. Will you have time during the exam to be able to do that, or do you have a class right after?
Okay, Dylan. Okay, did you? I don't recall. Did we talk before? Did we talk
About
before?
my-
Did you have something? Did you have something sent to me?
Yes.
Okay, no problem. Then Dylan, what'll happen is the test will be open from 8 in the morning through 7 o'clock. And
Okay.
specifically, I will mark on the test that you are to be given double time. Okay?
Okay.
Now, what that means to you is double time to me means a normal class period is 1 hour and 15 minutes. So you're going to get 2.5 hours. This means that you have to start the test before 4:30 if you want the whole allotment of time.
Okay.
That's fair enough?
Yeah.
Okay, good enough. Remind me again, Dylan. Remind me again on Thursday, okay, please?
All right.
So we
Question
just send you an
somebody
email
else.
about that? So we
I
just
can-
send you an email about that?
Rebecca, you are also?
Yes.
Okay. I will do my best to remember, but I will also email the class too. Yes, emailing me would be a great way to do that, all right? And I probably will email the class to ask that anybody that needs extra, that gets the extra time to go ahead and notify me. But emailing me is a great idea. Because literally speaking, at the end of today, my mind is fried.
Totally understandable.
Okay, anything else, guys? Okay, those of you that I'm seeing in a few minutes, I will send out an invitation. Those of you that I will see later, I will see you on Thursday. Been a pleasure. Take care, guys.
Bye.
See ya.
Bye.
Bye.
Bye, teacher.
Bye, man.